Okay, here we are talking about single displacement reactions. This is a follow-up to, I guess, our combustion, um, synthesis, and decomposition reactions. I made a mistake up here. This should be a number 3. This is our third. Actually, maybe it is our fourth type of reaction. Combustion, synthesis, decomposition. There we go. So it is number 4. It's the fifth type of reaction that I think I made a mistake on that. Okay. So these types of reactions involve an element and a compound where one element in the compound is displaced or replaced by a lone element. Okay, so it's going to be an element and a compound. So if you see a single element and also a compound as reactants, you know it's going to be single displacement. And then what's going to happen is the one of the elements in the compound is going to be displaced by the element that's by itself. Okay, and that's what this single displacement means. And then in order to kind of do these, we're going to have to use something which is known as the metal activity series. And I'm going to show you that in just 1 second, but we're going to use this here. Now, it's used to see if the lone element is active enough to replace the thing in the compound. Okay? All right, now, so this is the metal activity series. Now, if you go online, you'll see all sorts of other diagrams that look the same. This is just the one that I use because there's a couple pieces in here that I like to use. Okay. Now, the problem with this one is it was a scan and then it was a photocut or print and so on. So I've lost some of the articulation here, or the detail. All right. So there's supposed to be words in here, here, and in here. Okay. So the words at the bottom here is supposed to be low activity, or you can think of reactivity for the most part. And this is high activity for the most part. And the blurb up here is supposed to be, it's a metals, metal series. Okay. Now the way that the activity series works, and now this is not every metal on the periodic table. There you can find probably ones with more detail that go into all sorts of, every one being placed up here. So this is just a select few. Occasionally we'll find one that's not in our questions, that's not on the list, and you might have to just go online and check that out on your own. Okay, but otherwise we'll just be using this. Now this is all based on people's research, and they found that they've done these series activities, and they've seen which elements can combine which out of other compounds and so on. So that's where this comes from. Okay? Now the way that this works, and this is for the metals, is that this is the arrow I'm going to be using here. So this arrow here. Notice how it's an arrow here. Okay. So higher things displace lower metals. So what that means is if a metal is higher than another metal, so if aluminum, let's say, was the lone thing, and I was trying to displace zinc from a compound, aluminum could displace zinc because it's higher up. Zinc could not displace aluminum from a compound because aluminum is higher than zinc. And this has to do with the amount of, I guess, reactivity or activity that they have. So in the case of these two, zinc is not active enough to replace aluminum, but aluminum is active enough to replace zinc. Okay. There's a couple of things on here as well that are interesting. So this is what you'll use for metals. Basically, the higher the metal, it replaces something that's lower than it. Now, there's also other displacements that can take place. So you notice over here, there's one here that says displaces hydrogen from acids. And this is at room temperature without adding any energy or anything like that. Okay. So this arrow here is for acids. Now it's not height, it's simply they can. So anything within this area, in this arrow, can. So the first one here would be lead, and then everything above lead can. But hydrogen cannot, copper cannot, mercury cannot, and so forth. Okay? And the other bit of this is, can it displace from cold water? All right, so that's here. And the arrow works the same way as the arrow here. So anything that's above, all right, so sodium and above, they can displace hydrogen from water. Okay. Now these are displacing specifically hydrogen All right, so hydrogen from acids, and we already know that acids always have H so far, and then displacing hydrogen from water. And we'll show you what that means in a little bit. Okay, so you're taking one of the H's out of water. So in this case here, you would treat water as being something like this, right? And then it will displace the one H over there, and the one H. Okay. All right, so we're going to be using this to predict whether or not single displacements can occur. Oh, don't worry about this. This is something we're going to be using for double displacement, so don't worry about that. So this is all for single displacement predictions. Okay, this is what you use for single displacements. Down here, this is a solubility table, and this is for double displacements, which we'll do later. Prediction. All right, we'll talk about this as on another day. Okay. So type 1, and this is going to be related to that metal activity series. So this one here is going to be a metal displacing another metal. Then we're looking at metal displacing hydrogen, and then a metal displacing hydrogen again from water. Okay. So this is simply a metal trying to displace another metal. So here's my lone element. Okay, so this is my lone element, and this is my compound. And we're going to look at the metal activity series, and we're going to see if copper can displace the other metal. So then we go to our metal activity series, and we're going to look for aluminum, and we look for copper. All right, so we see that copper is here, and silver. Ooh, my bad. Silver is here. So copper is higher up than silver. So copper is going to be able to displace silver from the compound. So then we just simply rewrite following our nomenclature rules. Now silver comes out as a solid because it's just a lone metal. And then copper has a couple of different possibilities for its ionic charge. Let's just use 2 because it's bolded, but you could choose either of those. You don't know specifically what it's going to be, but let's just go with copper 2. So CuNO3 2. And we'll just say that it's still dissolved. All right, we won't make any predictions about that. Then we'll just make sure that we balance it. So 1 copper, okay, I need 2 of these, which gives me 2 of those, and then I think we're good. So another type is a metal displacing hydrogen from an acid. Okay, so here's my metal, and here is my H. So you treat H as an H+. So this would be H+ and Cl-. Okay. Even though it's technically, I guess it is when it's in solution, even though it's technically not, it behaves like an ionic compound when it goes into solution. So we're just going to look at the series to see if magnesium can displace H. So now, because that's an acid, we're looking along here, and we're simply looking to see whether it's within the arrow itself, not higher up. Okay. So our metal here is magnesium, and we're going to look for magnesium on here, and magnesium is right here, and it is within my orange arrow. So yes, it can displace hydrogen from an acid. So then we simply rewrite. So this is going to go where the H was, so it's going to be Mugglecoal, all right, 2. Oh, looks like I was maybe on the attempts of balancing there. And then the hydrogen comes out. Now remember, because it's not a metal, it doesn't just end up as an H. It's one of my diatomics, so it's going to be H2. And that's going to come out as a gas. Okay. This one was probably going to be AQ. And then we're just going to check that we balance. I got 2 of those. 2. Looks like I already balanced it previously to this. Okay. All right, now the third type again is that we saw in the activity series is metal displacing hydrogen from water. So again, we're going to use the metal activity series to see if sodium can displace hydrogen. Okay. So we're going to be looking on this part of the series, and we're going to look within this arrow, and it's simply a can. So we're going to look for sodium, and sodium is right here. So it is able to displace hydrogen from water. So then we just simply rewrite. So it's going to be Na. Now we treat this as H. Oh, I guess I mentioned it down at the bottom there. H+, OH-. Okay, that's how we're going to treat the water. So the sodium is going to displace this hydrogen. These other 2 are going to be intact. Okay, so sodium comes out, and it's a solid. All right, plus, and it's going to be Na Okay? And then I guess this is a base. So we've got AQ, and that's a solid. And then we'll just see if it's balanced, but it looks like I already started to balance it. So I'm probably going to need 2 of those. Oh, nope. My bad. My bad. This is not Na. Na ended up in here. This is going to be an H2 as a gas. All right, so let's see. We got 2. I'm going to have to make 2 of those. I'm going to have 1, 2. 1, 2. That's 4. That's 4. Looks okay. All right. Now, it is also possible for a nonmetal to displace another nonmetal as well. And for that, we don't need the metal activity series because we're dealing with nonmetals down here. Okay? So we're going to use something else, which is going to be described over here. Okay? So what we use instead of the metal activity series is we use the halogen activity series. And the halogen activity series is for nonmetals because all halogens are nonmetals. And we're only going to be looking at to see if these specific ones can displace other halogens. Now, I do give you a list here, most reactive, least reactive, but that's really based upon their position in the periodic table. Okay? So fluorine is the highest within the halogens of the 4 that you're probably going to encounter in this course. So fluorine can displace the ones below it. So it works a lot like the metal activity series, but it's only for this group or family within the periodic table of halogens. So fluorine can displace them all. Chlorine can displace everything except for fluorine. Bromine can displace iodine, and iodine can't displace anything. And that's what you would do. So this is your halogen activity series. This is just description into how the activity series works, but we'll quickly go through it after we go through this. Okay. All right. So we're going to see if fluorine can displace chlorine. So now we're dealing with halogen displacement. And so those 2 things there. Okay. So then I go to the halogen activity series. Fluorine is higher than chlorine. Therefore, fluorine is able to displace chlorine. So then you have chlorine come out, and it's a diatomic. We'll treat that as a gas. Plus the fluorine is going to go in there, so it's going to be NaF. And then we'll just make sure that we're balanced after that. I guess we're going to have to go with 2 on this, and then we're good. Then we're going to do the same thing over here. We're going to see if iodine can displace bromine. Iodine is lower than bromine, so it cannot. So we're going to deal with the situation, and this is for all displacement reactions if they cannot displace something. And this applies for metals trying to displace metals displacing hydrogen, halogens displacing halogens. It is not active enough. So iodine is not active enough. And the nice thing about the single displacements is you don't have to do a lot of work to determine this. You just use the series. There's different ways you can represent that there is no reaction as a result. So if I mix these 2 together, so if I had this in a solution and that solution, I poured them together, nothing would happen. There'd be no visual clue that the reaction took place. So we know that the one is not reactive enough to displace the other. Okay? So what happens in this case is you would write something like NR, which really stands for no reaction. Some other things that can take or can also be done. Sometimes they cross out the arrow to indicate that there's no reaction. But as long as you don't write anything on the other side, or even if you did write something on the side and then you indicate that there's no reaction, that would be fine as well. Okay? Now, if it comes to classifying, you would still classify this as being a potential single displacement, but it didn't take place. So it was potentially going to be single displacement, but then you would just say there's no reaction. All right. All right, let's quickly just go through the stuff on the back here, and then I'll set you on your way with your practice. Okay. Scientists have ranked their metals according to including H on activity series. The most reactive ones at the top are going to replace things that are unreactive, which are towards the bottom. And this is just how we talked about before. In the metal part of it, it's anything below can be replaced, but anything trying to replace something above it, it can't. So we talked about the arrows can from water and then from acids. And that's basically it.